A warm welcome to all our panelists and viewers from across the world to the second edition of World of Fenestration webinar series Tech Talk 2020. It is our pleasure to have you all here. We would like to thank our associate sponsor, Decunic India. On behalf of ET Tech and World of Fenestration, would like to thank all our panelists for joining us today. Our moderator for today's webinar, Ashish Puri, Director, Colliers. Joining him on the panel are Architect Karl Wadia, Senior Associate, Architect Hafiz Contractor. Pradeep Dwivedi, Head Project Management, Capitaland India. D. Vishwanathan, Director, Design and Projects, RSP India. Sudhir Kulkarni, Advisory Business Development, L&T. Swati Puchapalli, Director, Terra Viridies. We would now like to play a short video on Decunic India, post which I would like to hand over the mic to Dev Chandani, Director, Business Development, Decunic India, to give a welcome note. Thank you.
Good evening. Welcome to Tech Talk 2 show. I can see a lot of people are joining in and a lot of people are already there in the room. So most welcome once again for the Tech Talk 2. My name is Dev Chandwani. I'm the Business Development Director of the Decunic India. And I will take you through the journey of Decunic for 2 minutes and then introducing the speakers, and then we can start this webinar. This is number 2, PVC manufacturing profile manufacturing company from Belgium, and we are established in 1937, doing the successful business in 90 countries, and we are an 82-year-old company. We have 14 manufacturing plants worldwide, 22 distribution centers, and full-fledged technical support we provide to the developers and architects. Profiles India Limited, private limited company, is the subsidiary of Decunic Belgium, and we have successfully delivered 100 plus projects in India and successfully installed structurally safe window over 20 plus high-rise towers. We have 2 warehouses from where we distribute the this UPVC profiles. We have a 900 ton stocking capacity. We have over 35 channel partners across India for fabrication and installation work. And we have 2 warehouses and the 2 experience center in Bangalore and New Delhi. These are the of projects which we have completed so far, where we have installed these structurally safe UPVC windows. Taking much of your time, I'm going to introduce the speakers of the day, and we'll start with Karl Wadia. Okay, he started his journey in 1999 with a well-known legend, master architect and planner Hafiz Contractor. He is a senior associate Hafiz Contractor firm, and he's graduated from Academy of Architecture Mumbai and a master's degree from Columbia University, New York. Karl gained 3 valuable years in international experience in KPF London before his return to India, where he resumed his services to architect Hafiz Contractor. Karl leads an exciting studio of nearly 100 young designers, visualizers, and experienced technicians in his role of senior associates. Karl has played a pivot role in designing of some of the architect of his contractor's most prestigious project in master planning, high, middle, and affordable residential, commercial institutions, office, and work buildings. And some of the noticeable projects is in Amravati, has recognized in the international design competition as well, like Ascenda Sindwich, Parivartan in British Pilani, Goa, British Pilani, Hyderabad campus, Manipal University, Jaipur, Symbiosis School, Pune, Lodha World School, Palava, and Upper Thane, and Rail and Transport University, Baroda. Carl has spread projects newly, W54, very famous project in Mumbai, 25 South Residential in the Vadra Group, where it is spread in 450 acres of townships in Y-City in Panvel for Lodha and Vadra Group. And Lodha Group, his portfolio is Lodha Venzia, Amara, Sterling, Upper Thane, and Bel Air. Carl is the lead designer for 300 plus meter Minerva Tower, Piramal Reality Maharashmi Towers, gorgeous property projects at Kharghar, Bandra, Thane, Vikhroli, and Bangalore, and notably Rustomji Crown projects to name a few. Welcome, Mr. Kumaria, in this Tech Talk too.
Thank you, Dave.
Thank you. And the next presenter is Mr. D. Vishwanathan, Director Design and Projects, RSP India. Mr. D. Vishwanathan is a 1992 graduate from School of Planning and Architecture, New Delhi, and in 1996 postgraduated from the Urban Design from the same school. He is registered with the Council of Architecture India and has over 27 years of experience with renowned Indian and international practices on a wide range of institutional, commercial, retail, and residential projects. Started his career with a reputed Delhi-based practices, Raj Regional Associates, and then subsequently working with S.K. Das Consultant. He moved to Kuwait with consultant for a period of 8 years. During this time, he was involved in a significant range of the projects across typologies. Mr. D. Vishwanath joined RSP in 2006 and had since involved in the design of hospitality, commercial, retail projects. He now leads the Delhi NCR operations of the RSP India for the past few years. Welcome, Mr. D. Vishwanathan.
Thank you, Mr. Dev.
Thank you. The next presenter is Swati Puchalapalli, Director, Terra Veritas Consultants LLP. Swati is the Director of the Terra Veritas Consultant and a sustainable design consultancy firm and the Director of the Sustainability at Viratatwa, and in consultancy specialization in high performance design. She is having over 20 years of experience in sustainable designs and environment policy research. As a strong proponent of passive designs as the first step towards efficiency, she applies learning from local vernacular and uses state-of-art simulation techniques for the building analysis. She created Greha Evaluator, Griham Assessor, Greha TAC member, and visiting faculty at CET Ahmedabad. She did her BR from Hyderabad, MSc in Environmental Science from Hyderabad University. Ms. Swati Puchalapalli.
Thank you very much.
Now the next speaker is Mr. Pradeep Dwivedi, Head of the Project Management, Capital Lane, Indian Operations. Mr. Dwivedi has over 27 years of experience. In his current role, he's leading a team of highly motivated professionals. He's managing development projects spread in many Indian cities and supporting commissions for writers and Indian-focused real estate funds listed in Singapore. Welcome, Mr. Pradeep Dwivedi.
Thank you, Dev.
Now the next speaker is Mr. Ashish Puri. He's the Director of Colliers International. He is an architect with over 16 years of experience in designing and building workplace, retail spaces, institutions, mixed use and hospitality projects. He has worked extensively on the diverse portfolio and delivered world-class spaces all across India and abroad. He has been working with key global and Indian clients, some of which include GE, Boeing, Qualcomm, Wells Fargo, and Indian Institute of Management. Post his graduation in architecture from RVCE Bangalore, he has diligently pursued innovation, planning, strategy, and delivery in design practices, which has enabled him to take a leadership role as he heads the interior design services for Colliers in India today. Welcome, Mr. Ashish Puri.
Thanks, Mr. Dev.
Thank you very much. Last but not least, Dr. Sudhir Kulkarni, Advisor, Business Development, L&T Realty. Kulkarni is a graduate civil engineer with a master's degree in marketing management. He also completed his doctoral studies in the affordable housing after having worked in reputed companies like Mahindra Lifespace, Imar, Raheja Universe. He is currently working an advisor, business development with L&T Realty, and he has over 35 years of experience in the real estate industry. Well, Dr. Sudhir Kulkarni.
Thank you for the introduction.
So, sorry. Once again, I will welcome all esteemed panelists, and without wasting much of your time, because around 200 plus, 300 plus people are waiting to listen to all our panelists. So, handing over to our moderator, Mr. Ashish Puri. Over to you, sir.
Thank you so much, Dev, for the wonderful introductions of all the panelists. Thanks a lot, and good evening, everyone. It's my pleasure to welcome all of you at this creative evening webinar on a very interesting subject, which is the data-driven design. That's like the buzzword in the design industry. So for years, for example, design has been driven, by a lot of factors. From love, we all know Taj Mahal, to livelihoods, from forms to functions. The famous architect Louis Sullivan, at least he believed in that form follows function. And today, here in the middle of 2020, all of us are sitting, the architects, the consultants, and we have a new puzzle here, the data-driven design. And, we're going to have insights from our expert panels, all of them having diverse experience. It's a power-packed panel, I must say, on the subject. We will also touch upon, concepts of comfort, of well-being, the biophilia, as well as the energy. So we'll start with this. And, let's start with the first question. So what we have two sessions here for today. The first session, we have about 15 minutes for the first session. And how I would like to begin is that the first session, we will talk about the core subject, the core topic, which is the data-driven design. It's like imagining that we are probably in around January 2020, and then COVID hasn't happened. So we'll start with that, and then we'll come during the session 2, we will come and address the concerns what we face today. My first question, is about, it's starting with the basics. The first question to all the panelists is that, do you guys think that data is actually driving the design as of today? Or is it the clients? Is it the budgets? And what we as professionals can do to ensure, where do we see this going, So I would like to invite probably Swati, you can go first at this question.
Thank you, Ashish. Interesting question. And the answer I would say is that I think as a design practice, data-driven design is picking up. It's been very common in Europe for several years now, very common in Singapore and Australia as well. But in India, I think it's just picking up. We've been seeing a lot of interest over the last 2-3 years. So I'm very hopeful that data becomes a major part of design development.
All right. Carl, you want to go next on this? Your viewpoint on this subject. Where are we headed?
So it's a good question. Who's driving design, data or clients?
Yeah.
First and foremost, let's get it out of the way. It's clients driving projects. That is without any shadow of doubt. Now you have a couple of types of clients. You have the real estate client who's only looking at data in the form of numbers and rupees and revenue and valuation. You have the institutional client and the university client who's looking at creating legacy and spaces. Not that the real estate client is not, but I think data presents itself in so many various forms that and we're lucky to be architects, because you can sort of take all of that data, and then it depends on your mood or your feeling on that particular day, which data you want to process and make a design out of it. And then how you pitch it to a client could be another set of data. So
Interesting
data.
perspective. Yes.
Yes, so it's always data, but I think coming back to today's subject, data when it comes to biophilia and to create very, very appropriate design is something which no longer can be ignored under any circumstance, along with all of the other data that is obviously required to produce good design.
Right. I would now invite Mr. Vishwanathan to, have his perspective on this subject before we move on to, other two panelists. So,
thank you, Ashish. I actually tend to agree with Carl a bit. There are two types of clients, those which are end user driven and those which are speculative user driven. So I think when it comes to the speculative user driven projects, there is little value for data which is pertaining to sustainability, its engineering and other aspects, but more focused on budget and cost. But we've seen that when it comes to an end user driven client, there's definitely a far more emphasis on data driven. In fact, it says by the fact that the sustainability consultant is on board when the architect is on board. And that really happens only when it's a user driven project more than any other types of project.
right. So thanks a lot, Mr. Vishwanathan. So let's go to Mr. Kulkarni now. Let's hear his perspective. He's representing L&T, so let's hear it from the developer's perspective.
Typically, a design brief is given to the architects with all the total wish list that a typical developer or a client would like to imbibe in the design. And then the architect comes out with his own creative presentation, which is more generative in nature. Then the whole the developer has to really sift through it, see how many of his wish list parameters are fulfilled, and then there's an iteration of the design. We keep on. There is always trying to reduce cost, reduce increase occupancy, and that
to and fro driving the designs. Then
no, it's not that. At the end of the day, the project has to be sustainable. It should. Everybody is there for some profit. It's not a charitable job that they are doing of providing office spaces or residential spaces. So, end of the day, it has to fit into the overall financial parameters. Right. So and then the discussions begin to and fro. End of the day, we have to convince the architects with hard data representing the environment, statistics on cost, everything. And then after a long process, we come to the final acceptable design. A lot of valuable time is lost, and time is money for the client. So ideally, if at the first place itself, if the design is driven by data, it would be a win-win situation. It will save valuable time for the architect also, and we could launch the projects quickly.
Point taken, sir. Point taken. Let's move to Mr. Pradeep, and let's hear him out about his perspective. What does he feel about this whole scenario?
Yeah, Ashish, in my view, when it comes to the design has two parts. One is data, another is intuition. And like it or not, whatever data we can create, we cannot actually write off intuition completely. There is a lot of things that actually intuition puts into the design, and that we can call a building that has a beauty and the brain. So brain comes from the data, because you know that by operating the building, you measure the performance and you know that what kind of a data is required to design a building that has a brain. And then when it comes to the beauty comes from the intuition. And yes, there is when you are saying that whether the data is driving the design, I would say that customer's choice is driving the design. Because whether it's a developer or a consultant or whosoever, entire AEC industry, architect, engineer, and construction industry is actually working for the customer. So whatever customer wants, we only put that into the form of data, and big data helps us to make this more objective design. I think data-driven design helps everybody, helps the architects, helps the engineers, and helps the entire construction industry. With this, we can get a better product at very reasonable cost. And yes, there is I think a little bit problem, because in construction industry, when it comes to the performance data, there is no platform where performance data is shared. It's basically a proprietary data. Every organization keeps that data with them, and when the architect comes on board, they give, hey, I want the building to be designed based on this data. Let me ask a question. How many of us are having that? Which building is consuming how much water, how much electricity, and other things? So similar way, I think, you see, if the other industry like the airways, what they did, they made that data available for everybody. But in construction industry, it's not happening. I think it will take time, because if we see in the AC industry, data collection is only 12 or 15 years old. So once the data becomes available for everybody, it will be more helpful. But yes, we are gradually progressing towards that.
Right. I think, yeah, that's a very apt answer, balanced answer. And I think it sums up what everybody has in mind. Yeah, so thanks for that. So I think let's move to the next question, which I would like to ask Dr. Sudhir. As you're one of the leading developers in the country. So what are the key data parameters, which you think are the most important when it comes to the building construction industry? What are, you could highlight just three, the most, in terms of priority, but what are the key data, what you're looking at? If one architects come to you, what would convince,
Now, post-COVID is now really going to change the way architecture is done. And, my first requirement would be that it should meet the norms set by the International Living Future Institute by fulfilling the standards of living building challenge. This is something like a BIS, Bureau of Indian Standards, and the building code and all that, but which is more based on biophilic design. What does this mean? It means use of biophilic environments as an impediment element for having health and happiness of the employees. It should connect directly or indirectly with the external and internal nature. It should have proper abundant use of natural sunlight, and it should reduce the carbon footprint. That would be the first need. Secondly, it should be low on touch. Primarily with this COVID scare, it should be low on touch, high on automation. There should be ample digitization, use of artificial intelligence, and the spaces will have to be redesigned for making space for screening of visitors, hand wash. Then we'll have bacteria resistant paints and abundant natural plants and some extent water bodies. The third thing that I would like is 100% intake of fresh air for air conditioning and use of biofilters for purifying the air and preventing ingress of bacteria and virus. Of course, this will enhance the cost. So this cost should be offset by enhanced productivity due to enhanced mental health and happiness. There should also be substantial reduction in cost by judicious use of natural ventilation, natural light, forms, structural forms, etc. So that it should result in lesser energy bills. So these three would be top of the line.
All right. Okay. Yeah. I think that's a fair expectation from the architects. I think as responsible consultants, that's what we believe in as well. So let me come to the next question, and this is about what are the challenges we're facing, in implementing the data-driven designs. This is again, I'm linking it back to achieving good health, well-being, and comfort. And I would, like Mr. Vishwanathan to take up this question first.
Okay, as an architect, here are a few challenges that I think we face. One, I think there's an immediate pushback often because it means there's a direct relation to the cost that comes into
yes.
play. But having said this, as Mr. Kulkarni was saying, you really have to persuade the clients. He was talking about persuading the architects, but we really have to persuade the client the value of how some of the data that is available to us or that can be generated from a site and a project can be used in creating a better space, a better environment for people. There's this intangible advantage of having a good space which can create a better health for people. Just as a small example, people who in their residence are more concerned about their energy, but the moment they go to the office, it becomes somebody else's problem. If we can somehow bring that into our design, that saving energy or better living and comfort is responsibility for all of us at all places. It doesn't matter whether it's residential or commercial. I think there'll be a better push towards a data-driven design, in my opinion.
I think, yeah, very well put. I think responsibility, that's a sort of habit which we all need to sort of build into us, that, you know, it's the same whether it's the office or it's our own house. You know, how about Mr. Pradeep, you want to, you know, take this question and have your insights on this, that what do you think are the major challenges? I know that, you know, the moment we talk about data driven design, the common notion is that, you know, you're increasing my cost to 20%, 30%. So how do you address that?
Okay, so there is two part of it. From where the data gets generated. Data gets generated when we design a building. Our consultant design a building and we construct, and that building goes in the operation, and then we measure the performance of that building. So data is normally coming from there, that now how the next building should be designed. And if we take that, that those data are going into the design of a new building, actually you are trying to optimize the next building design, and it's making more suitable for your customer. So I am unable to understand that from where the cost will increase. Data is not, whenever you see you are going to use data, actually you are going to satisfy your customer more at the optimum cost. Let me give just one example from the engineering industry. You design a building, and suppose for a 500 kilonewton per meter square, you design a building, a floor plate. And now you go and design the same building with a 3. You cannot compare it. But when you put, suppose, the sensors below the slab, and then you measure that actually how much actual load is coming on that, next building you can modify. Whether code is allowing you or not, that's a separate thing. But if you can prove, code can allow it. Question is that whatever data, whether it's data, let me give another example for the building industry. And that's basically the aircon industry. So earlier, nobody was measuring that what is the pollution. Nobody was knowing 2.5 PM, 2.5 PM 10. But now when people started measuring, what happened in the industry? In the workspaces, in the AHU, people started using double filtration. Now, 0.1 micron is also getting filtered. In addition to that, what had happened on top of this, to improve the well-being, people started putting UVGI. So I don't think that, yes, there is an incremental, but at the same time, you are going to satisfy customers. So choice is whether you want to have your product better and better, or you just want to stick with a lower cost. I think lower cost is one of the things, but lower cost cannot always be the best cost for the customer, for the best product. So I think we should look at that what we are going to get and at what cost, means optimum cost. So in my view, it's not increasing the cost, rather than it's optimizing the cost.
Right. I think the challenge with what most architects face is the moment, you know, they propose that we want to do a you know, IoT based lighting, the first question comes at how much additional it's going to cost me, even though there is savings. But I think once we have the data with us and we can actually show them that, okay, this is going to reduce your cost in terms of your energy savings over next 5 years, I think that's something which is have to be built into the designs. That was just my short perspective on that. So let's move to the next question. Carl, I'll address this question to you. And, a little off this subject, what we would like to understand from you is the correlation between the energy simulations and the data-driven design. You've been working on a lot of this, doing a lot of research on the subject. So if you could quickly explain to the audience a correlation between that.
Can you repeat the question? Correlation between?
The energy simulations and the data-driven design, energy simulation.
Okay, so I'll answer it in a little bit of a layman's language, because as architects we try and see everything from a visual perspective. So whenever data is presented to us, we as architects we look for an opportunity within data. So if for example, if my colleague says Swati is presenting some data which presents an opportunity to do a different building skin, or to do a different a different USP for the building, we'll grab it with two hands. It's just the nature of the thing, and then we will promote it to the client like it's the next best discovery. But having said that, we are sensitive about cost, and when energy simulations and all are done to prove why floor plates need to be a certain depth, why you need certain lux levels in a building from natural light so you can compensate as less as possible with artificial light. All of that is a byproduct. But to speak very honestly from an architect's point of view, we are always looking for that next aesthetic opportunity that can be found within the data. It's just a very frank and honest answer.
No, I think fair enough. I mean, that's a very fair point. So let's move on to the next question. Swati, that's to you. The last question of this session. Swati, we're talking about biophilia. We've seen biophilia evolving, getting a lot of traction within India as well. So what we would like to understand from you is that is there enough research to suggest that biophilic designs have the potential to change how humans as we as humans perceive the built spaces, in context to the data-driven design?
Yes.
We look at biophilia more from aesthetic purpose, pleasing, green, bringing in plants, but how does it, do you think that there is enough data to suggest which, that this is the future?
See, biophilia as a concept has been developed based on how people perceive their built spaces. So it's been based on concepts of why some spaces have a certain reaction, whereas others don't, right? So there's a positive perspective and a negative perspective to any space. Positive, the way people perceive could be positive or negative. So biophilia has been based on these principles. So essentially, this also goes into the concept of people and anthropology of human beings, etc. So there is enough research, both qualitative and quantitative, that has come up over the last 5 to 10 years, which talks about both the qualitative and the quantitative benefits of biophilia. But the crux of this issue, or the most important thing one needs to look at when one starts integrating biophilia, is to balance it out, integrate it so that it doesn't compromise or any of the other factors of, let's say, energy efficiency or comfort or, health of the occupant. It cannot. So going back to one question you had before, data, if you take data and taking away from what Carl said, if you look at data, it depends on how you look at data. You can look at data individually, so each data point can be looked at individually, or data can be combined and looked at holistically. It depends on how you look at it and how you derive and what you derive out of it. So I think there's a lot of scope in integrating and balancing various aspects of design with the help of data. And, I think I'll just sort of talk about that a bit more in my presentation.
Sure. So I think thanks a lot. I think we had the first session. I think we are almost in time, and I think we'll have the presentations, Now, I think, Swati, I think you'll go with your presentation first.
Yeah, I'll. So, good evening, everyone. So, what I'd like to discuss, can everyone see my screen? Is that clear?
Yes, Swati, it's visible.
Okay.
Yeah.
So, I'd like to start off, it'll be a very quick presentation. I'm just going to go through a few slides of what I believe is data-driven design and how it can help with design decisions. So data-driven design, from my perspective, is about balancing people, profit, and planet. It's about informed architectural design that can help, balance these things in a built environment. Now, we all know about what data can do from an energy perspective. We know that it is about combining design with technology. It's about optimizing design. It's about solving problems. It's about setting very high performance benchmarks, ambitious targets, and reaching those targets with the help of design. But actually, in reality, unless this high performance energy design is combined with health and comfort, that it can actually become a sustainable design that that can actually last a long time. So what I mean by this is, if a building is energy efficient but not, let's say, as comfortable, people will find quick ways to retrofit it in the most inefficient way. So that's why comfort and health are very, very important. Same goes with health as well. That brings us to the point of, what do you mean by health? Why do certain places feel good? Why do certain places appeal to people in general than others? We can go back a little bit about, it's all about how people are, I believe, hardwired. Anthropologists have sort of given us that kind of research-based evidence to say that people are actually hardwired to respond to nature. And they respond to the same relationships in architecture as well. So architecture which relates to nature always has a better response than otherwise. So what does that mean? And this is what biophilic design, as I had mentioned before, is based on. It's based on several, as you know, I won't go into details, but if I have to look at some extremely basic architectural interventions, it's about visual connection, thermal variability, daylight, and connection to the natural systems. Now, as I said again, there are both qualitative and quantitative benefits, both biophilia and comfort. And qualitative are many, starting from stress reduction, cognitive performance, improvement in moods, people feeling better health, etc. And there are several quantitative benefits that have come up over the last 5 to 10 years that a lot of research has gone into. These are some numbers from Harvard and MIT. Which says that if one goes through the way of biophilic design, it actually increases the speed of learning, it improves people's cognitive, and there have been certain numbers that would help, some data that has been put together that helps in taking this argument forward. Similarly, there's also quantitative benefits to comfort. That have come up through this kind of research, saying that daylighting and lighting actually helps people sleep 46 minutes more per day. So these kind of quantitative data is available right now that could help builders and help clients make a decision or go towards a certain direction. So now, how can all this be brought together? How do you bring together energy efficiency, comfort, health? Are there tools available that can help you make design decisions early on during the design stage? And that's what I would like to sort of quickly give you a very quick glimpse on. So there is data available, and this is the data that actually that combines energy, comfort, and well-being, and principles of biophilia that can be developed or that can be derived from various different tools available that can be used at various stages of design. And this actually could form the basis for design development. So let's look at which parameters are affected at which times of the, there are very early design stage, you have a whole set of requirements from the client, from programmatic requirements. But at the same time, there are also other information that is also available, such as climate, such as sustainable design targets, what are the site resources available. So at every stage in design, apart from the standard set of information or parameters that are available for the architect, there are a whole set of other design data that is also available that relates to energy, comfort, and health. And what are these? There are several manual tools and calculators. There are several design tools that can be used at very early design stages, which look into climate analysis, which look into radiation, and a little later stages of design as well, which look at how to space your buildings, how deep should your floor plate be, what if you space a building if you space buildings together in a master plan in a certain manner, what would be the wind flow through the site and around the buildings. So all these kind of design tools are to arrive at this kind of information. There's several tools available that give you this kind of data. Now, how do these tools help? They help you arrive at orientation, form, etc. They help you arrive at spacing and height of the buildings. They arrive at floor plate depths. They can help you arrive at facade design. They help you arrive at design glazing, specifications. They can help you arrive at different types of shading that are appropriate for various types of facades. It also helps you arrive at interior layouts. And how does this help? What do all these, when you arrive at all this based on data, what it can help is in developing a design which has good daylight with visual comfort, which is low amount of heat ingress that eventually leads to good thermal comfort, good amount of ventilation and natural ventilation that results again in lower lighting loads and lower heating loads and lower energy use. So the way that one could approach design to be able to balance energy comfort is to look at comfort first and say, if you make a building comfortable and use building design principles to make a building comfortable, and also principles of biophilia and health, if you take that into this equation, then it will automatically, in a way, lead to a very efficient design. So just a quick glimpse into the kind of data that can be derived. So at a very early master planning level, there are several tools that are available. There is climate tools, solar tools, wind tools that are available, which can help in understanding what the climate of a place is, how the climate can be taken advantage of, what are the times of the year when the climate, when one can have a greater connection to nature without impacting either comfort in any way. There are tools that can help you understand what is the there are tools that can help you understand the impact of orientation, what is the balance between spacing between buildings and the height of the building, so that you do not compromise on it in any way. So there are several tools this way. And once you develop a certain form, there are again tools that can help you analyze a building based on how much, what are the solar gains that are there on the facades, on the whole site, how does wind and sun interact with the form that you have come up with, and how the external spaces are, how comfortable are the external spaces during different times of the year, and what are the various things that you can do to make those external spaces comfortable. Now, why are we talking about external spaces? That's because, again, we go back to the concepts of biophilia, where we're talking about the connect between the inside and the outside and connect with nature. So unless you make the external spaces comfortable, you are not actually connecting creating a comfortable connect. So that is why design of external spaces for comfort is actually as important as design of internal spaces. Now coming to the next part, when you get into more detailed design of the building level, there are again tools available which help you balance daylight and glare. There are tools that can help you balance the impact of various facade elements, skylight elements to your visual comfort. There are tools that can help you understand the performance of your envelope, not just with relation to energy, but actually in relation to how comfortable you feel and how comfortable you are within the space. This is all in this particular, these things relate both to conditioned and unconditioned spaces. Conditioning doesn't always result in comfort. And there are also tools that are available where for similar type of walls or same type of walls, which have similar thermal performance, how comfort varies for different types of wall typologies, just based on how they are constructed. And they might end up with the same energy result, but comfort might vary quite a bit. So these are some of the data that is available, some of the data points that can be picked up during various stages of design that can help balance energy, comfort, and health and biophilia. And of course, when you're looking at a combination of conditioned and unconditioned spaces, there is again several tools that help you, that will give you the data to understand which of your design methodologies are working how well against another. So all this, however, requires an integrated approach to be able to use this data and convert it into a design language, understand how this data can be integrated into a design to make the right impact. All requires an integrated approach. It also requires an iterative approach. There is no cookie cutter solution. Every building is unique, and we will have to do this kind of study for probably every building to be able to get it right. What has it resulted in? It has resulted in fairly good results, both in terms of energy. This particular campus that we are talking about has the largest net zero energy building in the world as of now, as of today, 3.5 lakh square feet of net zero energy building, with 100% of the energy being generated on the rooftop and on the roof of the car park next to it. And it has used much lesser water uses, and other parameters fall into play. What it also brings about, this particular campus also has unobstructed views out, which means that the need for blinds is zero. You don't need any blinds. So which means that the envelope has been designed and the floor plate has been designed in such a way that you can use daylight and have unobstructed views out throughout the day from any direction, from any orientation of the building. This is what biophilia is, and this is what connecting your inside to the outside means, I would believe. And all this, again, all this comes down to cost. And this is one place where cost has not been greater to do all this. We didn't have to spend a lot more than a standard building. In fact, it was a little lesser as well. And this is how it came about. When you optimize, or when you start spending some money extra on the, let's say, the envelope of the building, there are offsetting and there is optimization that is possible in your cooling loads. There are optimization that is possible at your systems. So this is how cost can be balanced. So energy can be balanced with cost and comfort. So that's me, and I'm going to end it here, saying that data has a large part to play in helping arrive at a design that balances energy, comfort, cost, and principles of biophilic design.
Thanks, Swati. That was quite an immersive experience, taking us through the biophilia and the role of data in building the future buildings. Let's go to our next expert, Carl Wadia. He also has a presentation for us. So Carl, let's start with your presentation for our guest.
Yeah, am I audible?
Yes, Carl, you're audible. Go ahead.
Okay. Okay, so I'm going to try and run this as quickly as I can. So I think an offshoot of the word data-driven design is informed design, and the basic concept of informed design is not to approach a project with a premeditated design solution. Very often, a plot or a plan or a sort of project comes to you, and you have a premeditated design solution available for that, but rather to allow the environmental behavior and all of the all of the surrounding aspects of the project inform your design. So with this, I'm going to show three projects today. One is the Manipal University in Jaipur. The second is a catalytic startup mixed use scheme in Amravati for the ADP Singapore Consortium, and which was an international design competition. And the third is the BITS Pilani campus in Pilani, Rajasthan. All three projects were actually approached with no sense of premeditated design. We had a problem in front of us, and we had to sort of solve that problem uh, through design, but using a lot of data. So Jaipur, as you know, is land of the kings, a lot of color, art, also extremely hot and arid climate. So the first thing we did is we started looking at vernacular architecture, why this vernacular architecture has thrived over the years, and we had to design um, a student settlement of nearly 12 to 15,000 students in a plot of land given to us, which is about I think 55 to 60 acres. So the first thing that we started to do was we started looking at these medieval towns and how buildings are huddled together to create extremely intimate spaces, and using the bylaws of the city, and one of the directions given to us by Swati, who was our sustainability consultant for the project, was to bring the buildings as close together as possible, to make them orient them north and south, to shade the east-west axes. And with that, we developed this concept where we were able to actually not use the entire 55 acres, but do what we needed to do within 35 acres. So what you can see on the left-hand side is some diagrammatic concepts we showed the client, where the final, the final, sorry, the final solution was to create these two medieval villages. On the left, we had to segregate the boys from the girls. So with these town center squares in each of these villages. And what you can see on the right hand side is, when we started the project we started actually in December 12th, the design. You can see we've hit plinth by 1st of May 2013, and by November 16, we had developed the entire student campus of nearly 10,000 students with supporting infrastructure like food courts and sports facilities and all of that in a completely zero energy campus. Now, some of the data used while designing these buildings, so you can see on the left hand side and in the middle, these are all the irradiation studies that we did with Swati's office. On the bottom right, you can see the wind studies that were done. Each of these courtyards, each of these spaces was actually studied. Buildings were twisted and turned to get the perfect result. And the campus, which is actually built, this is what the spaces look like. Whether it's an east facade or a west facade, or a north or a south, every facade has a different chhajja dimension based on the analysis done. We had extremely low budgets, so everything that you see is actually painted on the buildings. There is no ornamentation whatsoever. all of these windows and all painted using the sort of colors of Jaipur and Rajasthan. What you see on the right hand side is there were places where there were important apertures required for each of these courtyards to get natural breezes flowing at a ground level. So, we grabbed that opportunity to create these fantastic portals that connected multiple spaces. That again added a lot of character to the campus. These are just some more photographs. The next building we did on the same campus was the academic block, which, like Swati mentioned, is a net zero building. So what you see down on the right hand side, you see west facade, south, north, and east, and you see a different section showing the windows. So each facade, the boxing dimension, the size of the window, the thickness and density of the jali, everything was different, but disguised within the overall architectural context of the building. So that, because this building was built on the opposite side of the campus where there was a pre-existing architectural style. So we had to retain that. But all of this information was brought into the elevation to sort of inform the design in a way so that you had classrooms which could be operated throughout the day without ever rolling a blind down, which was a fantastic achievement. So this is the look and feel of the whole Manipal campus, and we've been lucky. We've won a lot of awards, 5-star Griha rating, and many awards for this campus. The next project I'm going to quickly move through is a design competition we did for the ADP group in Amravati. We were fortunate to be the winners of that competition. Unfortunate that that project is no longer happening. It's a big mixed-use project with residential, office, a hotel, and a huge park which had to be activated. This site was almost touching the government complex which was under construction, and this was aimed to be the very first business business district or the business project in the city of Amravati. So there was very, very big aspirations. We went through multiple design iterations to finally come to the master plan. You see, I'm not going to be able to run you through that, but once we arrived at the master plan, and we arrived at the master plan through these iterative studies that we did, trying to inform the design, you can see that we ran a thorough analysis, be it wind, irradiation, UPI, all of that, to finally inform the elevations of the building. So what you see here is we picked up one example. So this is one building, and you can see on the right hand side, the south, east, north and west facades are all being heated differently, and since they are having a different sort of heat gain, the solution for each of the 4 facades had to be different. There could not be one single elevation that just wrapped around the building. So you can see the north facade, for example, almost has no louvers or no fins whatsoever. And the other facade that we felt we needed to deal with was the terrace of the building. So that again had its own design solution with an amphitheater and all of that. This is the opened out elevation of the same building. So you can see how the north and the west, you'd be surprised why west. It's because in the master plan, there was a taller building just adjacent to this. And you can see on the right hand side, there's a different design solution for each facade. So even though we put louvers, we made sure that the louvers blocked the west and the east sun. We made sure that the natural ventilation was brought in from them, so that you had cooler breezes. And this is the final the final elevation of the building. What you're looking at is the west and the south facade. This is the overall complex and how it works overall. And the last project is that I'm going to show you is what we did in Bits Pilani, Rajasthan. So here the challenges were completely different. This falls in district Churu, which is actually the hottest place in India, just 3 days ago on May 25th, Churu had a temperature of 47.5 degrees. And in the winters, the average is about 10, but typically around January 15th, it hits 0 or sometimes even -1. The challenge in this site was we had to create an academic building for 3,000 students sitting in a very old heritage campus. And sorry. And you can see on this slide, you have this grand old clock tower, you have a Saraswati temple, and the site was right in the middle. And we had to use all of this land to create this campus, but also keep it thermally comfortable. So what we did is this was our design, sorry. This was our competition entry. We made a model where we kept all of the old heritage buildings intact, and we actually submerged, or we made the entire campus subterranean. So the objective was to create this building with no architecture whatsoever. So this was the no architecture solution. Today, if you look upon this campus, you can see that the whole building is below ground. From the street level, you see no building at all. Only when you enter the campus from the street level, you can see the image on the bottom left going down. You have these portals with Rajasthani arches that lead you down. And this final image is of what the campus looks like today. This is a real photograph of a 2.5 lakh square feet subterranean building. That's all from me. Thanks.
Thanks, Carl, for taking us through your wonderful works integrated with data. Thanks a lot. We would now go to Mr. Vishwanathan, our third expert on the panel. He has a short presentation for us. This is the last set of presentation. After that, we move on to a very quick, short panel discussion.
Thank you so much. That was wonderful, Carl and Swati. My screen is visible, I hope.
Yeah.
Yes, it's visible.
All right. So I'll take you through to a corporate campus that RSP is currently working on in Noida. And clearly, one of the basic challenges that we had is balancing the whole iconicity, the place, the form, the shape, the function, efficiencies of floor plates, as well as very, very strong goals that were set for sustainability and energy consumption for this campus. Very large project spread over 25 acres with very high FAR, almost FAR of 3 that leads to a very dense mass of buildings that we needed to create. So, some of the first initial sketches obviously were more form-based. The client and the brief was very clear that this must be the most iconic building that's been done in NCR. And therefore, the starting point really was from these sketches that we did, and then worked out very efficient central core office spaces with adequate depth of about 11 meters that bring in adequate daylight right to the central part of the core. So, and then also look at how the roof of the building, as well as various levels in this project, can be used for collaborative spaces and other kinds of spaces that address biophilia by creating gardens and terraces at various levels. From a site perspective, like I said, we had about 27 acres with 3+ FAR. So we really had an FAR close to about 4 million square feet that we needed to consume. And the mandate was very clear that we're going to do that. There was obviously the way the site was planned is where immediately our response to the climate and the location started to kick in. So the north-south direction as the longer direction then became a very critical element of how we set the master plan and how each of these buildings talk to each other. and then set the whole landscape and the scheme within that parameter. Green office was something that was definitely in the brief, and because it's an end user driven building, the consultant, in this case EDS, who I'd like to give credit for working with us on that, generated numerous data points for us that we could then use towards the design of this building. So once we looked at the form, and it is obviously a design that started with the form, but had various elements of data that was given to us from an energy performance that then formed and shaped the whole building. So while there was a certain sense of preconceived idea of what we wanted to do with the project, there was absolutely no preconceived idea of how we wanted to evolve the facade. The facade is organic in the sense of it developed from all the inputs that EDS, our consultant, started to give in, and then we adjusted the plans and we adjusted the whole form and shape to match those numbers. So different sides of the building then began to take shape. The flow plate itself is actually quite simple, rectangular flow plates, but then begin to reduce as they go up and then morph themselves into these facade forms that go in and out and in triangular planes in this building. This is about 200 meters tall building, if I may just set the scale. But right at the outset, the client did set very, very stringent targets for us. The project goals had some of the lowest targets for the energy performance index. And coming in Noida, that was obviously going to be one of our biggest challenges to get to that 50 kilowatts per hour. And they already had targets for us from the envelope load, from the cooling demand and the peak electrical demand. And then all the data that was generated by our consultant was then used towards getting to this. Building is obviously LEED Platinum rated, and that was a given mandate for us in this particular case. So we summarized all that we're going to target from a data point of view. We did want to look at facade. We wanted to look at the selection of the materials for the facade. We wanted to look at how natural ventilation can be brought into this building. We wanted to do geothermal cooling. We were also looking at radiant cooling as different MEP systems were explored in the project. Looking at the soil, rainwater harvesting, and also creating this idea that you preserve the biodiversity by creating spaces for birds to nurture and the plants to nurture within this overall master plan. The solar glass, which would generate electricity, is also part and parcel of this whole thought process. So as a starting point, why the angles, why the shapes? So part of the reason is really looking at studies that we did from a glare perspective, from the visual glare or the sky glare that would come into these offices, and then look at how we can shape and organically morph this building so that some of these glare elements are cut off from the insides of the building. And then an overall idea of how this all turned up. Obviously, some parts of the facades were on the west. What we did was we punctured the building into it. We created that buffer of green at every alternate level to take the actual usable facade deep inside, while the front, which faces the west, has greens. We have a naturally ventilated food court at the base of the building, and then morphing the shape at different locations and play with the facade to create the best orientation for the building. A quick look at two studies. There's obviously a lot more detailed. I've tried to compress this in about 8 or 10 slides for the paucity of time. But you can see that pretty much the way Carl was showing in his presentation, every part of the facade was looked at, and then the angle at which it needs to incline to ensure that there is less glare as well as less thermal, the heat inputs into the building. That was studied. And then once we had the form, once we had the basic surfaces, then we went into shading devices and other shading elements. So as you go down the presentation, you will see that each of these facades take a different shape and a different form and a different shading strategy simply because of their orientation. So on the right, you see all these studies of angles and shapes and how these were input into some of the softwares that Swati was talking about earlier to generate results for us that would then determine how big a shading we need, how big a fin we need. So on the left, what you see, extreme left is what you see is the section, and you can see how the inclined facade goes there, and then intermediate spaces, which then become gardens at various levels. And at the roof, again, create biophilia. When you create a garden at the roof, which is useful, which is used, but at the same time, it's protected from the wind that would blow at that kind of a height. From an actual facade point of view, we did use the idea of a light shelf to bring in which is that piece of glass and that shelf here, which would then bring in the light inside in a reflective and a diffused manner. We did have to use a lot of those fins, and they do have different angles and shapes based on the surface that they occur and the orientation that they occur. While the whole building is in glass, you could see that the amount of daylight is also controlled by what is spandrel and what is vision in this project. So we also studied the model. Like we said, there are various buildings. Two of these buildings are not shown on the model because they would be in the future phases. What you see as a very long building is a multi-level car park. And then that's the phase 1 building, that's the taller one that you see here. But then there are two more of similar sizes that will eventually appear in the campus. From a design vision, what we did was we looked at what the ground level pedestrian activity would be, and we wanted to incorporate all the different elements as a continuous space making with the tower in the background. So this building has a courtyard in the middle. This is, of course, the high-rise building with a garden at the top. There's a food court that happens at the base of the building, which is naturally ventilated through this terrace at the top. At the same time, the central plaza with one basement and a larger part of the site devoid of basement. So one of the things we've kind of observed is basements kill trees, because you always fight over the soil depth that's available to you. So the multi-level car park actually begins to balance some part of it, and you're able to get more natural fast-growing trees or high-growing trees within this campus. Quick snapshot of how we finally conceived the building. So if you just look very closely, each angle has a different type of fins, and that's really to do with the orientation. So some of them have at angles, some of them are horizontal, some of them are thicker, and some of them do not have fins. So depending on which orientation they face in the project. So a closer view of the base itself, where each of these is now clearly visible. The glass selection, of course, is based on EDS's recommendation for thermal performance and getting the right U value and getting the right shading coefficient. So it's a dark glass, but it still affords a fairly good light transmission for people from inside to have a view outside. Okay, and then as we enter towards the lobby, you begin to bring in elements of biophilia. There are gardens, not just at the base level, also at the roof, vertical gardens, protected. I know how difficult it is to grow some of these gardens in the Delhi environment, but once they are a little protected with these shading devices, they begin to do much better in an environment. And then, as I spoke about, both from a thermal reason as well as health and mental well-being, these terraces or gardens on the west facing at every alternate levels bring in some quality, bring in some nature, even though you may be at a 60-story or a 50-story building. And then that then percolates not just into these terraces at the alternate levels of the west face, but also on the roof as well as in the lobby at the base. And that's the overall view. So I hope I'm in time. I had a slot. So thank you so much, Ashish and the rest of the team.
Thanks, Mr. Vishwanathan. Thanks, Carl and Swati, for taking us through wonderful presentations. A lot of data in that, to absorb for all the participants, I'm sure. And some wonderful points, I think. Just great presentations, great designs. So with that, let's move forward with the next session of the discussions. I think we're running a little out of time, so we'll keep it short and quick. So I think all the consultants had, good time, showcasing their data-driven designs. So let's go back to our friends from the developers who are representing the developers. So let's go back to Mr. Pradeep, and then I'll come back to Dr. Sudhir.
Ashish, can I interrupt? Sorry,
Sure.
I really had a hard stop at 6 o'clock. I've already stretched it to 6:20. If I may be
Thanks a
permitted,
lot
I really have to quit the meeting. Thank you all. Thank for all the participants who attended it. I am really sorry. This was meant to finish by 6. I just stretched it to 6:20. I have another meeting, so I've got to leave. Thank you so much. Thank you.
Bye, DV.
Bye. Thanks. Yeah.
Bye, Mr. Vishwanath.
Thank you. Bye.
So like how we discussed in the beginning that the second session, let's try to address the current situation. I mean, we saw some wonderful buildings, and all of us would love to go back to those buildings as soon as possible. I'm sure everyone on the panel, participants, whoever is watching, they're all very keen to get out of their houses and go back in using these buildings. So my question to Mr. Pradeep is that how do you think we were prepared as industry to handle such a situation? And what do you think the role the data plays now to handle something similar in the future?
Okay, Ashish. So you see that the current situation is unprecedented. And nobody has seen this kind of a situation in the past. So honestly, there was no data, and all the buildings which are designed, those were not designed considering this kind of a situation. So this is a hard reality. Now, because we have this kind of a situation, now we have to basically make these buildings function in this kind of situation. So let me put that how this entire thing, this COVID situation, is affecting the building and its occupant. So let me put this into 3 buckets. One is that pre-COVID, where all these buildings are designed and everything was normal. Then during COVID, and then after COVID. I think at this point of time, nobody has the clear idea that when we will reach to the situation where we can say that we are in post-COVID situation. I think we all have to learn to live with COVID. So more important is living with COVID. And if we have to live with COVID, then what are the challenges? Entering the building and reaching to the workplace. There are many touch points, whether it's entering, putting your card, and then allowing you to enter by using a flap barrier and then elevator and then entry at the door. So all these things need to be made touchless. In addition to that, whosoever are occupants, they are going to use some of the amenity and facilities, toilets, food courts, so all those spaces also need to be made touchless, fully touchless. In addition to that, when somebody is going to work at the workplace, though it's going to be sanitized, but the bigger challenge is that sanitizing the air, means disinfecting the air. And I think a few of the developers and in the industry in last few years consciously people, though not for the COVID, but for the wellness, people had started putting the UVGI in their AHUs. So that is now going to help to basically disinfect the air when it's coming into the aircon space. So these ways, I think we learn to live with the COVID. I think at this point of time, whatever data we have, I don't think it's enough data. And even the medical practitioners and doctor, even the WHO, we all are trying to find out that how this disease actually spreads. You know, initially that it was coming like a 1 meter social distancing, then it changed to 1.5 meter, then it changed to 1.8 meter. So I think this is too premature to see that we have all the data. But yes, I think it's a good time to understand from the information and whatever data is coming. And once I think medical professionals are very clear about the data, spread pattern and other things, we can use this data to design the next buildings. And consciously we have to make, I think, the entire building touchless. Whatsoever a person is going, it must be touchless. No touch point. I think it's a given, irrespective of whatever the result comes from the COVID. But most important is that we have to design a building that can test the scrutiny of the COVID.
Right. I think some very valid points you made there about a future which is contactless. You also made a very valid point about the acceptance that the virus is not going to disappear. So we need to learn to live with the virus. I think that's the kind of situation we're looking at. Next question is to Dr. Sudhir. So what we would like to hear from you is that what's the, I mean, no, it's a difficult question. We are in a difficult situation, but what is the real estate industry looks like from here on? The outlook, what are the changes which is going to happen, and how can data help us eventually, you know, to also improve the existing buildings? We have a lot of buildings. We have, you know, the workspaces, commercial buildings, retail. So what do you do with all the existing buildings available?
Well, typically the start of every century has led to changes in architecture. Way back in 1810, 1815, we had the TB pandemic in Europe and America, which led to the sanatorium movement, and the redesigning of the entire New York City happened. What did they do? They went for slum and ghetto clearance, decongestion of the city, taller buildings, and more green spaces. Come 1918, 1920, the flu pandemic, we got the Corbusier design set in, minimalistic ideology, curative environment, clean and smooth surfaces, eliminate needless clutter, keep walls and floor clean. Now again we are into 2020. So it's a bit of a lot of coincidence, but again in 2020, what is the post-COVID era going to offer us? It will lead to a renaissance in design thinking and practice. Public and personal health issues and policies will become more of a customer need, and it will hence become a design determinant. The incorporation of nature in built-in environment is going to be the new norm post-COVID. Biophilic design will become a greater part of discourse in architectural, mainstream part of collective architectural thinking. It is going to usher in an era of biophilic design, and real estate developers will have to accept this fact, and the existing buildings will have to have retrofits, as Pradeep mentioned, and the new designs will have to follow all the norms laid down by Carl and Swati. I think there is no escape. Cost will follow. First thing is we need to focus on what the customer is going to demand and what are his expectations, and we'll have to exceed his expectations and lead him to joy and happiness. So keeping that in mind, the real estate industry will have to rethink strategies on cost. Even if think of new building technologies, new materials to contain the cost, but there'll have to be a paradigm shift in the way business would be conducted in future.
Right. Thanks, Dr. Sudhir, for those wonderful ideas and your insights about how the future looks like. And I'm sure all the architects, all the consultants are now, it's again, I think, beginning of, you said it's a renaissance, so it's beginning of a new era in design. We're starting from scratch probably again on a lot of things. So I think
Ashish, let me add something. I was wondering, I think we go back to the 18th century, especially where Bombay is now become a hotspot of COVID. We will have to focus on slum clearance, decongestion of Mumbai city, have taller buildings and more green spaces.
No, absolutely. I think most of us would agree, rather everyone would agree that decongestion is something which we seriously have to look at. I mean, we have to have more cities, more satellite towns near Mumbai, so that these kind of situations can be avoided in future. I think with this, we're almost running out of time, and I think we can probably take some questions from the audience. There have been some questions. Let me just quickly. So there are a few questions. So there is a question from Ashish Balal. I'm not taking this question because he shares the same name, but I'm just taking this question because it's one of the earliest questions on the panel. So the question is: a detailed brief is the predecessor of a good design, and brief is obviously data-based. Data is the new oil which is fueling the economy. How do the architects in the panel feel about receding importance of design versus data in the present times? I think the question goes to Carl straight away without saying.
So good question that the data is the fuel of the brief and the design, but you'll be surprised very often, when you present a client with a good idea, the client is more than willing to modify their brief. So I think the brief cannot be the start and end all, because then that the person that sets the brief, that becomes the limitation of the design. So that would be unfortunate. I think it's the brief, it's the designer and the enthusiasm that the designer carries with him or her, and then sort of you come to a commonplace meet point where you sort of realign the brief between the designer and the client.
Establish a common ground, I think, is what you're trying to say, and then look at the whole thing. I think there are a lot of questions. I don't think we can take all of them, but maybe another question. So there is a question from Rajroop Sarkar, and the question is: can biophilia be achieved using artificial plants? Since a lot of clients decline natural plants because of maintenance required for it. Of course, the answer is no. But I think, how do you convince clients that artificial plants is not biophilia? So Swati, you could have you seen such a situation where clients say, okay, fine, we like biophilia, so just give us artificial plants?
I've seen that happen in many places. Not that I endorse it. Biophilia is not.
I picked up that question just to bring the seriousness of the entire discussion.
Biophilia is not just about greenery. It's not just about having greenery in building. Biophilia is about connecting to nature, connecting to natural elements like daylight and ventilation in an effective, efficient manner. So you cannot just look, if you look at biophilia, it's based on 14 principles. So you just can't pick and choose what you want. You'll just have to see what you can do with all of them together. Coming to natural plants, plants are not just about greenery. It's not just the color. It's about it being a living organism. It's about the air quality. It's about the oxygen. It's about a reduction of pollution levels, reduction of dust. So it comes with a lot of other things that plastic plants will not be. Plastic plants will only give you just the colors. I don't think that's a good solution to biophilia.
There are a lot of questions coming in, but I think we're almost running out of time. So probably we can take these questions and then respond to them at a later date. I think that's possible. So I would hand it over back to Mr. Chandwani I think we had a wonderful discussion with our panelists. It was a wonderful insights, you know, a lot of ideas, a lot of discussions, and we are looking at the future as well. So yeah, back to you, Mr. Chandwani.
Ashish, thank you very much for handing over. But let me share with this my personal experience with this webinar. It was so structurally organized by Mr. Ashish, you know, asking questions on spot, and the timing and everything was fantastic. And the more important thing is that the content and the information, what Carl, Swati, and Mr. Vishwanathan shared, and what experience Mr. Pradeep and Dr. Sudhir has shared is valuable to all the viewers as well. So I will once again thank you, Mr. Carl Walia, Mr. D. Vishwanathan, and Swati, and Mr. Pradeep Dwivedi, Mr. Ashish Puri, and Dr. Sudhir Kulkarni for attending this Tech Talk 2 under the umbrella of World of Administration and sponsored by Decorative Profiles. I will thank you very much and have a nice evening to you. And we will be keeping in touch and hope we should have such kind of interactions to bring value addition to the marketplace. And we'll update you about the next webinar series to all the speakers so that you can also take the advice. Thank you very much and good evening to you.
Thank you so much. Honored to be here. Yeah, thanks a lot. Yeah.
Thank you, everyone. Thank you, Ashish.
Yeah.
Thank